Okay, so for this question, I've just scanned in my working instead of writing out the whole thing because it's a pretty long question and it's really hard for me to make things look neat on this little Wacom tablet. So we're going to be using mathematical induction to prove this. So we're going to be using the tape method. So you first test when n equals 1, then you assume that when n equals k, that is also true. Then you prove that k plus 1 is true, and then you evaluate. So first thing that we do is we test n equals 1. So I've substituted, either you can take the first term here and then you prove that the right-hand side is equal to that first term in the left-hand side, or you can substitute into this section here with when n equals 1, and then you substitute in here when n equals 1 to prove that that will be true. So that's why down here I've written cos 0 because that was our first term in the sequence. And then I've also used this to show that that would work to get you the first term in the sequence. I believe you only have to show one of them. I've just done both just in case you've chosen to go for the different method. Now the right-hand side, I'm just substituting when n equals 1 up there. So down here, when we're converting our right-hand side, the problem that we've got at the moment is I've got 2 of theta inside the bracket. So in order to get one of the thetas, I'm going to use the double angle formula from the formula booklet. And I've chosen this one out of the 3 because the other ones have sine terms in it. And if I use the sine terms, then I'm just going to create another problem that I have to solve, which is getting rid of the sine. So I picked the one that's only got cos in it. That way I can cancel out these ones later. So my 1s will cancel out because 1 minus 1 will make 0. The 2s will cancel out and I'm just left with cos theta. So then I have proved, therefore, that left-hand side equals right-hand side. Now, I haven't written that in there, but it should definitely be in there. So therefore, left-hand side is equal to right-hand side, true. Whee! Okay, so the next thing to prove is that we are going to assume that n equals k is true. So I've written it out again and I've replaced anywhere with an n with a k. So that means that all of this is now equal to this, and I can say that that statement is true. The next thing to do is to prove that when n equals k plus 1, that is also true. So I'm going to replace everything prior, because really what it means, n is equal to k plus 1, is like saying the next term in the sequence, that's the one we're proving, which means that the previous term in the sequence is just k. So that's why I've got here replacing all of this previous stuff with this one term here. So that's why I've highlighted this in blue and this is highlighted in blue, because that whole section gets replaced by that. So that's how we end up at this point here where I've got this at the start, which is just the part over here that's in blue. And then on the end here, I've got this part again, but with k plus 1 substituted in. Now, the next problem I have is I need to make the bases the same so that I can start manipulating the equations. So to do that, I multiply the top and the bottom by what's over here. So 2 cos theta, and that means now they've got the same base. Now, the next step that I need to do is to simplify it, and I'm going to do that by applying another formula from our formula booklet, which is going to be this one here. So if I move the coefficient to the front, I can see that I can represent this equation as 2 cos bracket 2k plus 1 bracket theta bracket cos theta. So in this case, this section in here is what we're going to be calling A, and this section over here is what we're going to call B. So if I look at the formula that we're given in the formula booklet, I can take this 2 and put it out the front here, and that will make it pretty much the same as what we've got there, meaning I can replace this section with this, and then we'll be happy. So I've done that down here by putting in A minus B, A plus B. Once I've done that, I get this statement, and then I can simplify it by grouping like terms. The thetas will cancel out in this case, and then over on this one, I'll end up with 2 theta. Then down here, I've just factorised that 2 out the front. Oh, sorry, I factorised theta out of it. so that I end up with this. Okay, so once I've done all of that, I'm going to substitute that back into this part up here. I did that separately just to make it a little bit clearer what happened in those steps, because I know that the QCAA booklet just jumps straight away. So we've substituted this back in here, and now this is what I'm left with. So once I expand out these brackets again, this is what I'm given, and then these two will cancel out. Now, the reason why they get to cancel, even though in this case I've got k and over here I've got k plus 2, is because if you think about what happens to that -1 when I substitute in a value for k, these two will always be the same. If k equals 1, then this side will be -1. This side will be -1 to the power of 3, meaning it's still -1. So in these cases, they're both still going to be the same, and this has a negative in front of it, this has a positive, so they get to cancel out. If k was equal to 2, then this would become +1, and this would become +1 as well, because k would be 4. 2 plus 2 makes 4. Anywho, so they get to cancel out. Now I'm going to factorise the 2 out of this section because I'm trying to get it to look like the right-hand side, which means I just keep manipulating it in little steps until I can get that to happen. Now I'm pretty close to getting it to look the same, except in their one there's a negative out the front. So in order to make sure that I can get that negative as well, I'm going to factorise a -1 out of this expression. Now you can see how I've done that over here. Initially it was -1 to the power of k plus 2. So that's going to be equal to -1 to the power of k plus 1 times -1 to the power of 1. If I have indices multiplying, it means that I add them together. So this statement, if I want to work backwards, would become k plus 1 plus 1, meaning it would be k plus 2. So that's how I factorised one of them out so that I can get this to become a negative in front. So you can see here I've done those little arrows to indicate how I got that one to change into being a negative using that one. Now you can see that I've got the right-hand side to match. So all that's left to do is my evaluating statement. So if n equals 1 is true, then we can assume that n equals k is true. So we have now proved that n equals k plus 1 is true by mathematical induction. And then that little statement is our final part, that's our evaluation.